Hello, everybody. Today we're going to talk about calculating the correlation R. So up until today, you've been given the correlation, but today we're actually going to learn two different ways to calculate it, both by hand and on the calculator. So how to calculate the correlation R? Well, there's 4 steps. The first thing is you're going to find the mean and standard deviation of S sub x of the exploratory variable. We're going to calculate the z-scores of the value of the explanatory variable for each individual. Then you're going to do the exact same thing for the response variable. You're going to find the standard deviation and mean and calculate the z-score for the response variable for each individual. So that's what you're doing here. Then for each individual, you're going to multiply the z-scores for the explanatory variable and the z-score for the response variable. Then you're going to add up all the z-score products and divide the sum by n minus 1. Here's the formula. So R is equal to the sum of all the z-scores of the x's times all the z-scores of the y's divided by n minus 1. Okay, now this seems like a pretty tricky formula, but it's okay because we're going to do it all in a little chart, just like we do with standard deviation to organize our thoughts. So example number 8, do touchdowns predict wins? The table shows the following number of touchdowns and number of wins for the 4 teams of the NFC West Division and the NFL during the recent season. We're going to calculate the correlation for these data. So the first thing we need to do is we need to find the standard deviation and mean for both our touchdowns and our wins. So what we're actually going to do is we're going to call our touchdowns the explanatory variables and the wins are y variables, which makes sense. The more touchdowns you have, it would make sense that we would have more wins. So wins is explaining the response variable. Okay, so what we're going to do is we're going to use our past calculator knowledge to actually find the mean and standard deviation for both x and y. So we would put these in a calculator, just like we did in Unit 1, and we find for our explanatory variable that the mean is equal to 40.5, and the standard deviation of our explanatory variable, S sub x, would be equal to 15.7. We'd also go and find the mean and standard deviation for our response variable. So y, or the mean of y, would be 8.75, and the standard deviation of our response variable would be 3.5 wins. Okay, so we're now going to use this information to find our z-scores and therefore our correlation. Okay, so you may have noticed that we switched screens. However, for some reason, the other program I was using was just not cooperating. So we're going to continue now that we have all of our means and standard deviations, and we're now going to find the z-scores. So what we're going to do is we're actually going to find the z-scores for the x variables first, and we're going to use these formulas right here. So first we're going to go for 58, and we're going to do 58 minus the mean of 40.5 divided by the standard deviation of 15.7. And when we put that all into the calculator, we should get 1.11 as our z-score. Then we're going to do the same for 49. So we have 49 minus 40.5. We're going to divide that by 15.7, and we're going to get 0.54 as our z-score. And we're going to keep doing this all the way down. So we have 31 minus 40.5 divided by 15.7, and we're going to get negative 0.61. And then we have 24 minus 40.5 divided by 15.7. That's going to give us negative 1.05. Remember, z-scores are rounded to the nearest hundredth. Okay, now we're going to find the z-scores for the y's. We're going to use this formula right here. So we're going to start out with 13 minus 8.75 divided by 3.5. We're going to pop that in our calculator, and we're going to get 1.21. And then we have 10 minus 8.75 divided by 3.5, and that's going to give us 0.36 as a z-score. Then we have 7 minus 8.75 divided by 3.5 in our calculator is going to give us negative 0.5. This is the exact number, so you could put a 0 there. It doesn't really matter. And then the last one we have is 5 minus 8.75 divided by 3.5, and that's going to give us negative 1.07. So now that we have all of our z-scores, we are now going to multiply all of our z-score points together to get z sub x times z sub y. So we're multiplying these together. There's a secret ninja multiplication sign in between these. Okay, so now that we have them, what we're going to do is we're going to take 1.11 and we're going to multiply it by 1.21. And when we put that in our calculator, we're going to get 1.3431. And we're going to keep the whole thing. Okay, no more rounding. So now we have 0.54, and we're going to multiply that by 0.36. And we're going to get 0.1944. Then we're going to have our negative 0.61, and we're going to multiply that by our z-score for the y, which is negative 0.5, and we're going to get 0.305. And then last but not least, we have our negative 1.05 times our negative 1.07, and we're going to find that in our calculator as 1.1235. So now we have all of our z-scores multiplied together. The last thing we need to do is we need to add all the z-score products up and divide by the sum of n minus 1. So r is going to be equal to 1.3431 plus 0.1944 plus 0.305 plus 1.1235, all divided by n minus 1. There are 4 points here, 1, 2, 3, 4, so it's going to be 4 minus 1. We're going to put that all in our calculator, making sure that you use parentheses for the different numerator and denominator, okay? And you're going to get 0.99. So our correlation is 0.99, which is very strong, okay? The association between touchdowns and wins are very strong. So properties of correlation. Now that we know how to find correlation by hand, which by the way, you're not going to have to do often, I'm going to show you how to do that in a calculator at the end of this video. Properties of correlation. So correlation makes no distinction between the explanatory and response variable. Okay, so you could actually flip them and you're going to have the same exact correlation. An example below is where foot length is the explanatory variable and height is the response variable. And after calculating, you get an R equal to 0.84. Now you could completely flip these numbers and you're going to get the same correlation. And that's because they're bunched the exact same way, even if they are slightly different because you switch them. But they're still as strong as 8.84. So again, there's no distinction between explanatory and response variables. 2, because R uses standardized values, the observations R does not change when we change the units of measurement of both Y and X, or both. So if we change from centimeters to inches, we're going to have the same correlation. So again, changing the units of measurement does not change the correlation. And finally, 3, the correlation R has no units of measurement. So you're not going to say R is equal to 0.99 wins. No units of measurement, okay? Because we're using standardized values in the calculation, and standardized values also have no units. So the formula for correlation involves the mean and standard deviation, and both variables are not resistant to outliers. So it isn't surprising that correlation is also not resistant to outliers. In fact, outliers can have a huge effect on your correlation. So in our last example of the day, I want to talk about these outliers. So the scatter plot below shows the relationship between height in inches and cumulative weighted GPA for a sample of high school students. How do the 2 points in red in the upper right-hand corner of the graph affect the correlation? And we're going to explain. So the majority of the points here, let's look at those first. So when you're looking at a problem like this, kind of ignore these points just for a couple seconds, kind of like ignore them. Okay, so let's look at everything else. Everything else looks like it's going in a negative direction, and it seems moderate, maybe even moderately strong. Okay, so let's write that out. So the majority of the points show a moderate to moderately strong negative association. So without those 2 points, I hope I spelled that right. So without those 2 points, this appears to be moderate and negative. It goes in the negative direction. However, when you add these 2 points now in the corner, when we stop ignore them just for a second, it's actually pulling it's making the correlation closer to 0. These 2 points here are now affecting the whole thing. It's actually making it weaker. Okay? So when we add the 2 points, it changes the association between height and cumulative GPA to actually be weaker. And some might even argue that it could even be positive now. So this was clearly negative before we added these 2 points, and now this line, or this idea that we have of it being negative, is now being drawn upwards. So this is now going from negative to possibly even slightly positive. But there's definitely a weaker association between the two when you add these 2 points up here in the corner. Okay, so the question of whether this example is representative of a larger population will be considered in later chapters. So this is actually the end of these notes. I also want to show you guys how to do things on calculators. So we're going to be switching to my calculator view now.
Okay, so now you should be looking at my calculator, and we're going to find out how to find the correlation, or R, on our calculator so we don't have to do it out by hand every single time. So what we're going to do is we are going to press Stat. That is our go-to button in statistics. Makes sense? Okay, and we're going to go to Edit, or 1. We can press 1, or as long as it's highlighted, we can go in there. And as you see, I already have the information in for our example number 8. We have our explanatory variable for the touchdowns in L1. So we have 58, 49, 31, and 24. And then we have our response variables for wins in L2. So we have 13, 10, 7, and 5. Also, just quick, I want to show you guys that you can actually clear the list by going up to L2. Never press delete. No, don't ever press delete, because once you delete your list, we're going to have to reset the calculator. So what you can do is you can press clear and then enter, and then everything in that list goes away. So again, let's put them in. We have 13, 10, 7, and 5. Okay, so now that we have this in our list, what we're going to do is we're going to press Stat again. Okay, we're going to go over to Calculate by pressing the right button. And you see we have our 1 variable statistics, which will tell you all of your means and standard deviations. But if you look, number 2 tells us 2 variable statistics, which again is the name of the unit that we're currently on. So it's kind of a little bit of a spoiler alert. Now our X variable, our explanatory variable, is in L1, and our response variable is in L2. Remember, you can change the list by pressing second and L1, L2, L3 down here if you need to. Okay, so then what we're going to do is we're going to scroll down to Calculate. We're going to press Enter, and boom, we have all of our 2 variable statistics. As you can see, we have our mean for the X's, we have our standard deviations for the X's, we have the number we have for the X's, and we can go down, and here's our mean for the Y's, here's our standard deviation for the Y's, and if you continue to go down, you'll see our 5-number summary. Now, what you don't see here is correlation, and what we actually have to do is we have to turn correlation on. So what we're going to do is we're going to go down to the bottom here, and we're going to go to Catalog. So you're going to press Second, Catalog. Okay, and you'll see this. Okay, you're going to see everything that your calculator can do is actually in this catalog. So what I'm going to do is I'm going to go down again to diagnostics on. Now you guys can scroll all the way down. As you can see, this is taking quite a while to scroll down. Or, just another little fun trick, you could also press alpha, and then if you look, there's a D in green right above this X to the -1 button. Okay, so what you can actually do is second D, and it will bring you to the first D here. So you can scroll down from there. So you found the diagnostics on. What you're going to do is you're going to press enter once you get there, and you're going to press enter again, and now it's done. Okay, so everybody needs to do this in your calculator if you want to find the correlation coefficient. Okay, so now that your diagnostics are on, what you're going to do is you're going to go back to stat, you're going to go over to calculate, and what we're actually going to do is we're going to go down to this button right here. It's 8, it says linear regression, not aggression. Okay, and this button's actually going to be very useful in our future, so remember it now. But if we push enter on this, it brings us to this list, and we're going to go down to calculate, because again, our explanatory is in L1 and our Y list is in L2. We're going to calculate, and when we do, we see our R is equal to 0.99, just like we calculated in the notes. Okay, now these things right here, these are going to be explained in the next section, so please note the buttons that we just did to get here. Okay, so remember though, in order to get R, your diagnostics have to be on. Okay, and again, that you have to go to the catalog, okay, and you have to go to diagnostics on. So that is actually the end of today's notes, and I will be in the chat if you guys have any questions. As always, contact me via email or go to the meet, and I hope you guys have a fantastic day.